All right, guys, so we're looking at the first few problems here, problems 1 through 7. Find the given measurements and remember your units. So when we look at these here, they're asking for the circumference, radius, and area, or circumference, diameter, and area of these circles. So the circumference of a circle is 2 pi r or pi d. The area of a circle is pi r squared. And the diameter is half the radius, or the radius is twice the diameter. So if we look at problem 1, since they gave us the diameter, the length all the way through from one side of the circle to the other and through the center, the radius would be 7. We could say 7 centimeters. Now the circumference is 2 pi r or pi d. Well, pi times d, pi times the diameter would be 14 pi. Any questions on radius or circumference? Are we good with both of these here? Now, area is going to be pi r squared. So for us here, that would be pi times 7 squared. Well, 7 squared is 49, so we would have 49 pi. And if we put the units, it'd be centimeters squared. So any questions on 1 or 2? Any questions on number 1? Okay. Now, if we look at number 2, they gave us the radius. And the diameter is twice the radius, so we could take 3.7 and multiply it by 2 and get 7.4. Now, the circumference is the diameter times pi, or 2 pi r. So we can say 7.4 pi, because the diameter is 7.4, and the circumference is pi times the diameter. Now the radius is going to be pi times r squared. The area is pi r squared, so we'll do pi times 3.7 squared. So we could say 13.69 pi or 43.008 if we wanted to approximate. Any questions on 1 or 2? Any questions on problem 1 or 2? Any questions on 3 or 4? Any questions on problems 3 or 4? Are we good with 3 and 4? 5, 6, and 7 are the exact same. So let's look at 8 through 11. Arc length is equal to the arc degree over 360 times our circumference. And the circumference is 2 pi r or pi d. So if I want to find the arc length, AC, well, the arc length AC is equal to the arc degree over 360 times 2 pi r. Now our arc degree is 75 because it's the same as the central angle. And they told us that the radius is 8. And at this point here, we can type all that into the calculator to get our answer. Or we could have said 10 over 3. I would have taken either one. Because as long as we get the same answer, or the same numerical number value, it works. Any questions on number 8? Questions on number 9? So 9 through 11, which one do we want to look at next? 10? Let's look at number 10. We want to find the length of AC. So AC is going to be our arc degree over 360 times 2 pi r. Now our radius is 5. And our arc measure would be what? It'd be 155 because the bigger arc is 205. So do 360 minus 205, which would give us 155. So that angle right there is 155 degrees, which means our arc degree would be 155. And if we do this here, 155 over and that would be it there. Now we could turn it into the decimal form, and that would be correct also. Any other questions on number 10? Yes. Is 2 pi what? Because this here is part of what part of the formula? It's part of the circumference. Circumference is what? R is R. That's the radius of the circle for this one here. Pi r. So the radius is 5. So that's where we get the 5 from. Does that make sense? Because it's 5 feet. Mm-hmm. Yep. If you have questions about the numbers, please ask, especially on the test. Any other questions on number 10? We go to number 10. Questions on 11. Any other questions on 5 through 11 before we move on to the next section? Huh? Okay. So we want two parts, AC and DC. So AC is going to be our arc measure over 360 times 2 pi r, but did they give us the radius this time? They gave us the diameter, yes? Well, the circumference, is it always 2 pi r? I don't know, what else could it be? Pi times the diameter. If I'm given the diameter, might as well use it, because if we divide 27 by 2, what am I going to do when I plug it into 2 pi r? We're going to multiply it by 2. We're going to get back to where we start. So we can just use pi times 27. Because I'll take either the fraction or the decimal form. I don't care which one it is, as long as it is the same number. Any questions on this here? Because we're only halfway through this problem, because we still need to find CD. Now, I do notice that AD is the diameter, so the measure of all those angles would add up to be 180, because half the circle is 180. So, for DC, well, really, I can take 180 and subtract 101 to find out what that angle measure is, which would be 79, because 79 and 101 does add up to be 180. So the only real change in the formula, or what we're plugging in, is it's going to be 79 over 360 times pi times 27. And I think this one here is just going to give you a decimal. Yeah. If you want the fractional version, it's 237 pi over 40. Yes. The radius is distance from here to here is, no, that's 5 feet. Because we have that little hash, it's feet. But on the test, if you have a question about it, ask, because that's just a unit marker. That symbol next to it is the unit marker. Because I try to make sure, especially with numbers, I try to make sure they're all about the same height, unless it's signified to be something different. Any other questions on these here? Does that make sense? Yeah. 5 foot. I'll rewrite that, especially on the review. Any questions on these here? We ready for the next set? Find the radius given the arc length. So when we look at this here, we're told that the arc length is 28 pi millimeters, is equal to the arc degree, which is well, we can combine these to make it a little bit easier to work with. 28 pi is equal to, well, we can do 70, all this multiplied together, pi. Seven pi over 18 r. Yep. Any questions on how we got to this step here? Because we just multiplied 70 over 360 by 2 pi. Now at this point here, we can divide both sides by 17 or 7 pi over 18. Now, surprise, surprise, we do get a nice number. I want to say 72. And really, that's going to be it. So we're really using that formula, plugging in what we know, solving for what we don't. Any other questions on this here? Now, if we wanted to on this one here, we could have started at the beginning and just divided 28 pi by 70 over 360 times 2 pi. I could have just plugged it in the calculator as 28 pi over 70 over 360 times 2 pi, and it would have still told me that R is 72. It would have done the same thing. So it's a little bit easier to type this in than it is this. Not by much, but a little bit. Any questions on this one here? Any questions on 13? Are we good with 13? Are we good to move on to the next one? Yes. Are we good with these two here? Huh? Yep, that's fine. Yes. Okay. Questions on 14 or 15? Questions on 14 or 15? Or do we feel comfortable with these here? Feel good with these? Okay. 16 or 17, which one do we want to look at? 16. So we want to find the circumference of the circle. Well, we know that the arc length, 61.26, is equal to the arc degree. Well, they told us it's 270 over 360 times what? Well, 2 pi r or pi d is what we plugged in the last few times, but 2 pi r and pi d are both what? The measure of the circumference. Well, what are we looking for? The circumference, yes? So I'm going to leave it as C. Because I could solve for the value of r, but if I find the value of r or the diameter, well, I've got to plug it back into the circumference formula to find the circumference. So here we can actually just solve for the circumference. Any questions on how we set this up? That's it. Questions on these here? Questions on 17? Are we good with 16 and 17? Okay. 18 through 23, to convert from degrees to radians or radians to degrees. So looking at number 18, is that a radian or degree measure? Degree. So if I want to convert it to radians, I take 20 and multiply it by what? Pi over 180. Number 21. 3 pi over 2. Is this in radians or degrees? What's the giveaway? There's one thing that gives this away, that it is radians. Yeah, it's pi. If it does not have a degree marker, some of the times I don't write the degree marker in, but if it has pi, it is automatically radians. We do not talk about degrees in terms of pi. So for this one here, we're going to take 3 pi over 2 and multiply it by what? 180 over pi. Because like I just said, if it's in degrees, we don't leave it in terms of pi. So we're going to have to multiply it with something with pi on the bottom, 180 over pi. Which gives us 270 degrees. So if we're going from degrees to radians, we multiply by pi over 180. If we're going from radians to degrees, we're multiplying it by 180 over pi. Because 180 degrees is pi radians. Those are equivalent. Because a full circle is 360. A full circle in radians is 2 pi. So really, 2 pi over 360 is the same as pi over 180. Any questions on 18 through 23? We good with 18 through 23? Going from degrees to radians, we multiply by pi over 180. Going from radians to degrees, we multiply by 180 over pi. Area of a sector. Do we want to look at 24, 25, 26, or 27? Which one of those four do we want to look at? 25? 24. So, the area of a sector, the area of our sector, I'll write it down here, is going to be our arc degree, so we can use 135 over 360 times the area of the circle, which is going to be pi times the radius squared. And what would our radius be? 9. Because what is the actual unit measure? It's 9 what? 9 feet. Because it's 1 hash is feet. Does anybody know what 2 hash marks is? Inches. 1's feet, 2 is inches. One more time. 243 pi over 8. And would this be the smaller section or the bigger section? Smaller. Because we just found this here. Any questions on this here? So we just did the fact that the area of a sector is the arc degree over 360 times the area of the circle. Any questions on how we found the area of the smaller sector? Now there's 2 ways we can go about finding the area of the bigger sector. One of them is taking the same formula and doing 360 minus 135 and plugging that measure in there. So 5 would give me 40, 2 would give me 60, and I believe it should be 225. And we'll do the exact same thing here. Pi, I have a feeling it's going to be 8. Huh? Because 225 over 360 times pi times r squared would be 405 pi over 8. is the whole circle is 360. I know the part that we found for the smaller section was 135. So I can do 360 minus 135 to get this other angle here, which is 225. Now, I said there's two ways we could have gone about this. The other way is that, well, I know that the radius is 9, yes? So the whole circle would be pi times 9 squared, yes? That's the whole circle. Pi r squared is the area of the circle, yes? The part that we know, the smaller section, was 243 pi over 8. I can take the smaller section away from the whole, which would give me the bigger, yes? If we do this, we'll actually get 405 pi over 8. Give us our answer. Go do the exact same thing. Any questions on areas of sectors? We good with these here? Any questions on 25, 26, or 27? Because these here, 26 and 27, are going to be the exact same thing. So we good with finding the area of a sector? 26. So they told us, so area of a sector is equal to the arc degree. Well, they told us it was 300 over 360 times pi r squared, and our radius was 5. So we're just plugging everything into the formula. Now, would this be the bigger sector or the smaller? Bigger. Well, 300 is our measure, yes? What's the whole circle? 360. So the only way that this would be the smaller sector is if the other angle was bigger than 300. Can we have an angle measure in a circle greater than 300? Not if one of them is 300. So the other one has to be smaller. Now to find the smaller sector, we can do the same thing. I can subtract 25 pi over 12 from 5 pi, or pi times 5 squared, or 5 squared times pi to get the other one. Or we can do 300 subtracted from 360, which would give us 60. And do the same thing to find the area of the smaller sector, which would be 25 pi. Yep. This other one should be 125 pi over 6. It should have been a little bit bigger. Yeah, the other one should have been 125. When we plugged it in for 300 over 360, it would give us a little bit bigger of a value, as it should be, because 300 and 360, both of them are divisible by 6. 300 is divisible by, not 6, just 60. Is 5 times, and 360 is 6, so 5, 6. 5 times 25 would give us 125. Does that make more sense? Probably wondering why the answers were different than what you got if you worked them. Questions? And the other reason I was noticing that was a little off is because, again, 360, 300 degrees, 60 degrees, 300 degrees is way bigger than 60, so our other number should be way bigger than 60. We should have a little bit of a disparity between them. Questions? Any questions on any of these here? Are we good with these here? All right. Let's look at the next set. Area of a kite slash, what was it? Rhombus. Area is equal to 1/2 of diagonal 1 times diagonal 2. So we can just look at these two here. So the area for this here would be 1/2 of, what's one of the diagonals? 16, because we have to add 8 and 8. It's the whole length. Because it's the whole length of the diagonal, they only gave us 2 parts, 8 and 8. So they add together to be 16. 9 and 13 add together to be 22. Well, 1/2 of 16 is 8. And 8 times 22 is 176. Or you can just type in 1/2 times 8 times 22 and get the answer. So if we look at 29, well, they told us one of the diagonals is 20 and the other is 37. So I can say 1/2 of 20 times 37 for the kite. Now this one's not too bad, especially if you're doing it in your head. 1/2 of 20 is 10, and 10 times 37 is 370. Any other questions on 28 or 29? Questions on 28 or 29? Questions? Okay. There are no questions on 28, 29. Are there any questions on 30 or 31? Questions on 30 or 31? And that measure of 10, I think, got a little bled out or whited out on your sheet. So are we good with 30 and 31? Okay. Let's look at 32 and 33. All of the polygons that we'll look at, and especially on the test, are all going to be considered regular. So the area formula for these here is 1/2 of the apothem times the side length times the number of sides. Now the apothem for this is 9. Our side length is 10. And how many sides do we have? 6. 6 sides, side length of 10, and an apothem of 9. Any questions on either one of these here, 32 or 33? So, 1/2. our apothem is, our side length is 12, and the number of sides is 5. And we can plug that in and get 102 flat. And that'd be it. Any other questions on these here? These here, 34 and 35, are the exact same thing. They're just telling you what the apothem and the side length are. And they're told you one is a regular octagon, so it has 8 sides. A regular decagon has how many sides? 10. Find the surface area of each 3-dimensional geometric figure. So for solid, surface area of a solid, that means it has 2 like bases. The surface area is equal to the area of the base plus the height times the perimeter. So when we look at the first one here, let's look at 39. We have a box. Now I'm going to signify the top and bottom as the base. Well, sorry, 2 times the area of the base, because we have 2 of them. Well, the area of the base is just a square or rectangle. It's going to be a rectangle. And the area formula for a rectangle is length times width. And if we do 24 times 12, we get 288. So that gives us the top and bottom. So that gives us the area of the bases, and we have 2 of them, so we have to multiply it by 2. Now our lateral faces, and we get that by multiplying the height, which is by the perimeter, which would be 24 plus 12 plus 24 plus 12, going all the way around. Now at this point here, you could plug all this into the calculator. Or if we do 24 plus 12 is 36, and 36 plus 36 is what? So the surface area for this solid is 2016. Any questions on how we found the surface area for 39? Questions on 40 or 41? So 41, our bases are both triangles. Now it is a right triangle, so the base is equal to 1/2 the height times the base. Now it doesn't really matter how we want to say height and base, but they're going to be the 2 sides that make up that right angle. So we have 9 and 12. Now 9 times 12 divided by is going to be 54. So the area of the bases are both 54, so we're going to do 2 times 54. Now the height is 40, and our perimeter is going to be 9 plus 12 plus 15. And again, at this point here, we can type all this into the calculator to get our answer. Would be the surface area for this here. All right. $43 equals 2 pi r squared plus pi r L. For our cylinder, 2 pi r squared plus pi r L would be the surface area. So 2 pi times the radius squared plus pi, our radius, which is 9, times the height. So it wouldn't be L, it'd be just H, because L is denoted as the slant height. Any questions on 43? So 44 and 45 would be the exact same thing. Now a sphere, put this in here, surface area is 4 pi r squared. A hemisphere, surface area is 3 pi r squared. So for 46, if we wanted to find its surface area, we would plug it in as 4 times pi times 9 squared. So it'd be 324 pi units. Any questions on these so far? Does it be helpful to have the formulas written down? So for a hemisphere, surface area is going to equal 3 pi times 10 squared. And for this one here, we would just get 300 pi. Any questions, guys? Any questions on any of these here? Any questions on any of these surface areas? Okay. We're almost done. Find the central angle of a regular polygon. So when we find, guys, we're finishing this up here. So do not be backing away. When we want to find the central angle of a regular polygon, we take 360 degrees and divide it by the number of sides. So for an octagon, we would take 360 and divide it by 8. And that's all we would need to do for this here. All right, guys, make sure you do have the formulas all written down because I will not provide them tomorrow. And make sure to start